and oils are necessary for your lubrication in your body. For preparation, it is also used for preparation of synthesis of various steroidal hormones and all. So yeah, they play an important role in your daily metabolism. Lipids, biles, and all, they are the parts of your fats and oils. So let's go for introduction. So fatty acids. So fats and oil basically contains fatty acids. They are called fatty acids because they have carboxylic acid due to the presence of COOH group. That's why they are called fatty acids. Degree of unsaturation of fat depends upon number of double bond present in the hydrocarbon chain of the fatty. So your carboxylic acid is linked to your alkyl group. Your carboxylic acid group is linked to a long chain alkyl group, and if that contains unsaturation, then there is said to be a degree of unsaturation. Degree of unsaturation, number of double bonds that are present. Okay, fatty acids may be saturated or unsaturated depending upon the degree of unsaturation. Degree of unsaturation in fatty acids, more would be chance of lipid oxidation. So the any unsaturation, this all lipids are prone for your oxidation and rancidity. Fatty acids are amphithetic in nature. Why? Because it contains both a non-polar hydrocarbon chain and a polar carboxylic acid chain. Okay, therefore they act as hydrophilic as well as hydrophobic in nature. So they are fatty acids are amphibic in nature because they contain both non-polar and polar substitution in the same molecule. That's why they are called because they have got carboxylic and alkyl group. So what are these fats and oils? So fats, oils and wax together constitute a group of naturally occurring compounds that are known as lipids. They are not soluble in aqueous solvent but are soluble in organic solvents such as ether, chloroform, benzene, and hexane. So basically they are triacyl glycerol. That is, they are esters of glycerol. That is CH2, CHO, CHOH, and CH2OH. So this is a glycerol. So they are the esters. So what are O? These fatty acids will form an esters with the corresponding glycerol moiety. So this becomes your constituents of your fats, oils, and waxes. Okay. So the classification of lipids. So they are simple lipids, that is fatty acids and alcohol. So they contain an fatty acid and an OH group. So they are fat. What are fat and oil? They are fatty acids and glycerol. Waxes are nothing but fatty acids and alcohol. So they contain a long chain acid and a long chain alcohol, waxes. So this is the classification. Complex lipids is fatty acid with an group. So phospholipid, that is lipid with a nitrogen and phosphorus acid. Okay. Phospholipids are nothing but an lipid, that is fatty acids on any fatty acid which contains a nitrogen base and a phosphorus. Glycolipid means glycolipids are nothing but they contain a lipid and a sugar. Lipoproteins means it contains lipids and a protein, and sulfolipids are they contain lipids and sulfur. Examples are phosphoglycerides, glycerol with fatty acid and phosphate, phosphosphingolicides, that is sphingosine, fatty acid and phosphorus, and phosphoinoside, that is your sugar moieties. Okay, these are the different examples. Next is derived uh, lipids, that is simple and complex. Steroids or your steroidal alcohol, cholesterol, they are some of the examples. Terpenes, isoprenes, which are and carotenoids, they are all examples of your lipids. They are from plant origin. The cytosterol, ergosterol, which is present in fungus, that is, it forms the cellular mechanism. So your fungi contains ergosterol and lancesterol. It contains ergosterol and lancesterol, which is your cell membrane, which is your cell membrane. So the outermost covering of your fungus is made up of ergosterol, which is a type of a steroid. Okay, so these are some of the examples of your derived lipids. Okay, then your adrenocorticosteroids, steroid hormones, natural rubbers, and all. They are the examples. Sesquiterpenes, if you see in Cognos, many of your plant products, they contain this terpenes, carotenoids. Okay, lycopene, which is present in your tomatoes. Okay, carotenoids in your carrots. So these are some of the examples of derived lipids. Other miscellaneous lipids like squalene, pentosine, and ketone bodies. Ketone bodies, which are the side products of your cholesterol metabolism. Okay, so these are some of the classification of your lipids. Okay, now the chemistry. So as mentioned, these fats and oils are nothing but triesters of your fatty acids and your glycerols. The triesters means three acids form an ester bond with a glycerol. So three acids, the fatty acids, form an ester with a glycerol. They are called, they are also called as triglyceride because there are three molecules of fatty acids which condense with one molecule of glycerol to form a fat or an oil. So basically it is what? Basically these are esters of glycerol. So the glycerol is CH2OH, CHOH and CH2OH. So the OH will form ester bond with three fatty acids. That's why they are called as triglyceride. That's why they are called as triglyceride. Okay. So next. So classification of fatty acids. How they are classified. Basically how the fatty acids are classified. Which fat? So they are classified according to the chain length, body requirement, degree of unsaturated, and position of hydrogen atom. Okay, so these are the various classification of your fatty acids. So according to the chain length, whether it's a short chain, long chain, intermediate, or a long chain fatty acids. According to the body temperature, body requirement, whether it's an essential or non-essential fatty acids, or according to the degree of unsaturation and the position, whether it's a cis or trans. So now let's go for the classification one by one. According to the chain length. Short chain fatty acids means fatty acids with less than six or less than 6 atoms hydrocarbon. They are short, they are called as short chain fatty acid. Short chain fatty acids basically are liquid at room temperature. But by the hydrolysis of tri fatty acid produce give a rancid butter flavor. For example, butyric acid. It is C4. Okay? C4. So your butter basically contains butyric acid, caproic acid and all. That's why you get a rancid state if you keep it outside because of the hydrolysis. Medium chain fatty acids means the fatty acids with a chain length between 6 to 12 carbon atoms. Okay, in the hydrocarbon chain. So if the hydrocarbon, the alkyl chain contains and 6 to 12 carbon atoms, such type of fatty acids are known as medium chain fatty acid. That is caproic acid, caprylic acid. That is caproic acid in C6, caprylic acid in C8. So these are the example of medium chain fatty acids. Now long chain fatty acids means fatty acids between 14 to 20 or 14 to 20 carbon atom carbon containing hydrocarbons are called as long chain fatty acids. They are a part of vegetable oils, fats, myristic acid that is C14, palmitic acid that is C18, C16 and stearic acid that is C18. So these are some of the example of very long chain fat, and very long chain means more than 22 or more than 22 carbon atoms in their hydrocarbon chain are called as very long fatty acids. These fatty acids cannot be metabolized by liver, but they are metabolized by peroxides. They may be an important physicopathological and harmful for human. For example, uric acid. So this long chain fatty, very long chain fatty, they are not good for our body. They are harmful for human body. So this is the classification. according to the chain length. Now according to the body requirements. So there are two types. Okay, essential fatty acids and non-essential fatty acids. Okay, what are essential fatty acids? Fatty acids that cannot be prepared by the body. We cannot prepare on your own, but we have to depend upon the diet. So they are obtained from the diet. So these are known as essential fatty acids. Our body is not capable to synthesize this. Example, linolenic acid, linoleic acid, and arachidonic acid. These are very much important for your vitamin D synthesis and various other steroids. Okay, so this is example of essential fatty acids are linolenic acid, and arachidonic acid. Non-essential fatty acids means they can be synthesized by your body and are not required from the diet. Example, palmitic acid, stearic acid. Okay, these are the examples of your non-essential fatty acids. So this comes in your exam for 2 marks. So just make a note of it. So fatty acids can be mainly divided into two classes, that is saturated and unsaturated. So what is saturated? Means all are, there is only single bond. There are no unsaturation. So such type of compound fatty acids are known as saturated fatty, means they are all single bond. So saturated fatty acids, what are fats? They occur when each carbon atom is attached to surrounding by a single bond, means there is only single bond. The carbon atom is completely saturated with hydrogen. The saturated fats have high melting point at room temperature and therefore are usually hard. Could lead to heart disease and high cholesterol. So all these fats which are saturated, so saturated fats they say are not good for our health. Okay, unsaturated fat, that is PUFA and MUFA, you keep on hearing in your advertisement of fats of oils. High concentration of PUFA or MUFA. This is the reason why, because they will be liquid and they do not clog. That's why polyunsaturated fatty acids are used, because to reduce the risk of cholesterol and heart disease. These are some of the examples of saturated fatty acid. Okay, caproic acid, capric acid, lauric, meristic, palmitic, stearic, arachidic acid, and behenic acid, depending upon the carbon. So they have on even number of carbon atoms. If you see, all this contain a even number of carbon atoms. Now let's go for the unsaturated carbon. Okay, the unsaturated fatty acids contain one or more double bond. Unsaturation means a double bond or a triple bond. So if it contains one or more then amount of double bond, then such type of fatty acids are known as unsaturated fat. They occur when some of the carbon are joined to the surrounding iron by a double bond. So if there is a double bond between two carbon bond, then it is known as an unsaturated fat. They can be monounsaturated fats such as which contains only one double bond, or a polyunsaturated fats which contains one or which contains more than one double bond. Unsaturated fats are many oils and have melting point below the room temperature. They are basically oils which have melting point below room temperature. Okay. So examples of, see, like saturated fatty example is palmitic. Monounsaturated fatty acid is oleic acid, and polyunsaturated fatty is linoleic acid, stearic acid, and linoleic acid. So these are some of the examples of monounsaturated and polyunsaturated fatty acids. So now, according to the position of the hydrogen. So if the hydrogens are at the same side, then it is across the double bond. It is known as cis, and if it is at the opposite side, it is known as trans. Example is oleic acid, that is the carbon double bond is between 9 and 10. So if you start from your carboxylic acid, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So there is an 18 carbon, that is oleic acid. It's an 18 carbon 18 carbon fatty acids which contains a cis double bond between 9 and 10th carbon. Oleic acid is nothing but a fatty acid which contains a cis bond between 9 and 10. The example of trans-unsaturated means elatic acid. It contains same 18 number of carbon. Only difference is that it contains an trans isomer. That is, the hydrogens are at the opposite side. The hydrogens are at the opposite sides of the double bond. Okay? Across the double bond, the hydrogens are on the opposite side, and the alkyl substitutions are on the opposite side. They are not on the same side. That's why they are called as trans. And the cis are most common than the trans. Okay, example elatic acid and palmitic acid. Okay, so that's some of the examples of unsaturated fatty acid, that is cis and trans. So some more examples of saturated like stearic acid: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Okay, now when there is a double bond, that is a 9. So there is a double bond between 9 and 10, the linoleic acid. So it is also C18 only, but only difference is there is a double bond where 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There is a double bond between 9 and 10 and 12 and 13. Okay, there are double bond between 9 and 10 and 12, and there is two double bonds. So these are the example of saturated, monosaturated, and with same number of carbon atoms. So this example you can write it in your exam for saturated, monosaturated, and polyunsaturated fatty acid. Okay. Now occurrence and composition. Now comes the occurrence and composition. So when there are three acid residue of a triglyceride are same, then the triglyceride said to be simple. So when all the three acids, which are attached to your glycerol are same, then it is known as your simple. Okay, there is a mistake. You should write ester. Okay, when all the three acids attached to the glycerol is same, then it is known as simple glycerides. When the three fatty acids are unlike or more than one type of fatty acid are present, then the glyceride is said to be a triglyceride. So when one of the fatty acid changes, minimum one is uncommon between the three fatty acids to form a glyceride, then such type of glyceride is known as mixed glyceride. So let's see some of the examples. Simple triglyceride means glyceryl stearate, means 3 stearic acid that is attached to your glycerol. Example of mixed triglyceride fat is glyceryl myristo-palmitate and stearate. So there is myristic acid, palmitic acid, and stearic acid which is attached to your glycerol. That is an example of mixed triglyceride fat. And example of mixed triglyceride oil is double bond present, oleic acid, linoleic, and linolenic acid which is present. So there are three different groups present. So this is how you try to find fats and oils. So there are different as an occurrence. Furthermore, they can be present as animal fat, vegetable fat, oil, and marine oil. When your animal fat is the main constituent of the storage fat cells. So this is what provides the protection to the animals against the harsh environmental conditions, and they are present as oil droplets, and when they die they become thick mass. That's why example butter, ghee, and other all animal fats. Vegetable oils are liquid fat present in seeds, nuts, and oil. That almond oil, coconut oil, they are examples of vegetable oil. They serve as a nourishment for germination of an embryo. Example, corn oil, coconut oil, etc. So, and the next is marine oil. They are obtained from animals like sardines, that is from your marine aquatic. Cod liver oil and all other examples of your marine oil. The properties, they have got short chain and medium fatty acids are liquids, whereas long chain fatty acids are solids. Melting point increases with the increase in chain length. The unsaturated fatty have lower melting point compared to that of the fatty acid with the same length because of the non-proper stacking arrangements which is present in your unsaturated fatty acids. Saturated fatty acids form hydrophobic interest, so they are having high melting point than that because of the stacking. So this is the explanation for the property. Physical properties, they are either liquid or non-crystalline solid at room temperature, colorless, odorless, tasteless in the pure state. Color of the fat is due to the presence of other substance, like you get yellow color due to the presence of keratin in butter. They're lighter than water, they're insoluble in water, they're readily soluble in organic solvent. They form emulsions with when agitated with water in presence of soap and other emulsions. This is you have prepared emulsions with arachis oil. Okay, so this is an example. They are poor conductors of heat and electricity and efficient insulators for human. They act as an insulator in animal body. So these are some of the properties. Difference between fats and oils. They remain solid at the room temperature fats, whereas oils remain liquid at room temperature. They are relatively more saturated and they are relatively more unsaturated. They are relatively high melting point. Your oils have low melting point. They are more stable, whereas oils are less stable. Examples of fats and oils: butter, or oil like coconut oil and all. Okay, so these are some of the examples you have to write. Now comes the nomenclature, very important. You should know. Many a times you visit, they say omega 3 fatty acid, omega 8 fatty, 9 fatty acid. What does this mean? Or delta 3, delta 9 fatty acids. So what does this mean? Basically, as word onic acid, because it is an acid, that's why it is known as onic. A-O-N-I, because this is a suffix that you put for your carboxylic acid. Basically, it contains AON. So decanoic acid means it contains a saturated fatty acids with 10 number of carbon. That's why it is not decanoic acid. The suffix enoic is used also used for your unsaturated fatty acid like hexane decanoic acid. Okay, so this can be used. EON instead of A, if it is E, then it is an unsaturated fatty acid. The alpha carbon is represented by the first carbon in the chain, that is carboxylic acid. So the carboxylic acid is given the word alpha. Omega represents the last carbon in the chain. If you see in this particular, the last 18th carbon is always referred as omega. The CH3 end of your fatty acid is known as omega carbon. Okay, remember this. The CH3 end of your fatty acid, if you see over here, the CH3 end of a fatty acid is known as omega. See, omega 3 means there is a double bond at the third position from the methyl end. So they say na omega 3 fatty acids and all. So omega 3 fatty acid is nothing but it contains a double bond at the third carbon from the methyl end of your methyl end of your fatty acid. Okay, so other thing is your normal nomenclature is delta, and subscript number is used to represent the position of the. So if there is a double bond in the chain, so delta 12 means, in the above example, delta 12 means there is a double bond between the 12th and the 13th carbon. Okay, there is a double bond between. So if you see 1 2 3 4 5 6 7 8 9 10 11 12, 13, 14, 15, 16. So there is, in this particular carbon, there is example, there is a double bond between 12th. So don't get confused between this thing. So there is one which is written in the red represents the omega, and down which represents the delta. So delta means the double bond which is present. So number of carbons and the double bond is represented by X to Y ratio. So if there is 18 carbons, so in this particular example which is written, it contains 18 carbon and there are 4 double bonds. And the positions of the double bond is represented by delta. That is delta 1, 2, 3, 4, 5, 6 delta, 9 delta, 12 delta and 15 delta. Okay. So this is how you can represent the structure. So let us see some of the that is myristoic acid. Myristoic acid means it contains a myristic acid. That is, what is myristic acid? It contains 14 carbon and there is a double bond, one double bond, and it is at the ninth position and it is of cis configuration. Okay, palmitoic acid, it contains, it's a 16 carbon with a double bond at one double bond at the ninth position. And if it is oleic acid, it is 18 carbon with one double bond. Delta 9 means the double bond is between the ninth and the 10th. Elatic acid, it is 18 carbon with one double bond, which is at the ninth position. Okay, and linoleic acid. Now see the example of linoleic acid. So it contains how much? Linolenic acid, it contains how many double bonds? Three double bonds, which are all of cis configuration, and the double bond is at ninth, 12th, and 18. So 18 and 9, 12. So it is an 18 carbon with three double bonds at 9, 12, and 15. This is how your nomenclature of your fatty acids are written. So if somebody says this, you should know at which position these particular compounds are present. Okay, so this is how you can write the structures and name the fatty acids. So now let's go for the chemical properties. So first property is hydrolysis of fats and oil. First property is your hydrolysis of fats and oil. So it is a process of reverse esterification. Hydrolysis is nothing but your reverse esterification. So you get your carboxylic and acid, your fatty acids and your alcohol back. So catalyst like acid can be, or enzyme lipase can be used. So what happens? You can see in the code. So what happens basically? You got an CHO, C double bond O, R, CHO, C double bond O, R, CH2O. So these are the ester. This in presence of acid or enzyme lipase. Okay, they get converted into corresponding alcohol, that is glycerol, and your three fatty acids, COOH. So this is nothing but your hydrolysis. This is nothing but your hydrolysis. So this is your first hydrolysis. Okay, that is reverse esterification. That is also known as saponification. Let's go for the next. So what is known as saponification? That is So this hydrolysis can take place when the hydrolysis O, C double bond O, R, CHOH double bond O, R, CH2O. If the reaction takes place in presence of a base, okay, if the hydrolysis takes place in presence of a base, you get your corresponding alcohol, that is glycerol, and your salts, corresponding salts of fatty acids. Then such type of reaction is known as the alkaline hydrolysis of fats and oils to produce your glycerol and sodium and salts of fatty acids is known as your saponification. Because why it is called saponification? Because soaps are prepared through this process. The soaps are prepared by these. Soaps are nothing but sodium or potassium salts of corresponding fatty acids. Soaps are nothing but what? Sodium or potassium salts of fatty acids. Soaps are nothing but sodium or potassium salts of fatty acids. So hydrolysis, there are three types of acid hydrolysis. You get your alcohol and your acid, your lipase, that is your enzyme lipase, and the third one is your saponification, that is alkaline hydrolysis means in presence of sodium or potassium hydroxide to give your corresponding alcohol or and sodium and potassium salt or of your corresponding fatty acid, which is known as soap, and this process is known as saponification. This process is known as what? Saponification. Next reaction is your, so in this hydrolysis, what happens? Soap formation. So when the soap is formed, the soap forms micelle. What is this micelle? So they have got an hydrophobic nature, that is your non-polar region, and a polar region. Okay, that's why they are called amphiphilic in nature, because they contain both hydrophobic and hydrophilic in nature. The soap solution forms a micelle. What is this micelle? They form, see, the outer one will be what? If you see, contains an R group. This is a non-polar group in a polar solvent to form a spherical clusters called as micelle. So in the outer layer, your carboxylic acid all will be in the outer layer, and your alkyl group will be in the, so they will form a circular film that is known as micelle. So that's, these are micelle, which is very much used in your soaps. So this is micelle formation. This micelle formation is because of this particular reason. So now next reaction is hydrogenation. So this reaction takes place where the fats and oil contains a unsaturation. When a fats and oil contains an unsaturation, it undergoes reduction or hydrogenation in presence of hydrogen and in presence of metal catalyst and hydrogen like platinum or nickel. If it undergoes hydrogenation, okay, it will form saturated. Your unsaturated fatty acids will get converted into a saturated fatty acid. So this is an example of hydrogenation. Next is, there are two types of hydrogenation. One is partial hydrogenation and one is complete. In partial hydrogenation, it is the process is adjusted. Only few of the double bonds gets, while the others are left as such. So you get a soft and spreadable product. So it is not too hard and neither it is too soft. So this is known as partial, where all the double bonds are not saturated, only few of them. Whereas in complete hydrolysis, you get a fully saturated fatty acids, and these are hard products. So these are the examples of partial hydrogenation and in complete hydrogenation you get a hard fat, whereas in partial you get a semi-solid fat, because not all, there is a selective hydrogenation of double bond. So these are the examples of hydrogenation. So this hydrogenation reaction, let us take one example of linoleic acid in presence of nickel. Okay, if you undergo a partial, you get an oleic acid, and if you undergoes a complete hydrolysis, you get your complete hydrogenation, you get your stearic acid. So these are the examples of your partial and complete hydrolysis, hydrogenation. Okay, please mention this in your reaction. This, write the reactions of fatty acid. This comes as a separate